hex. So all the stuff that we already discussed about what it is. Just know that there is a recycle bin and the files do go there, and that's the first place I look when someone says I accidentally deleted cat.doc. However, there's one more advanced thing that happens following this, and I'll explain that in a second, which is, so these are all the things, there's tools to actually parse the recycle bin and all the recycle bin files so that they actually give you the info back. And so rfidi-util is one of the ones that has been made. Rfidi means trash in Italian, so they called the tool rfidi-util. So you can actually process the recycle bin. What you see in Explorer when you're looking at the recycle bin is not a true reality. So if you're looking in Explorer, this is what I call a rootkit. This is one of the reasons I call it a rootkit, and that's this. If I'm on, let's say I'm on Windows, I go to the recycle bin and I look at this. This is not true. Okay? I'm not saying this didn't happen and Windows parsed this, but we don't have a deleted date in our file system. The only one that does that I know of is Solaris. Solaris is the only thing I know that has a deleted date built in its file system. We do not have one. So that is made up by a basic rootkit is what I would call it, because this processed it from a file called the info2 file on this machine. Otherwise it would have processed it from files called $i. So if I was on a machine and I am here, I mean, this is what it really looks like. This is the real data in that directory. That's what you see. The only thing that's not here that you can't see is the hidden file called the info2 file. The info2 file is a hidden file. I guess I can't even see it here. It's a binary file and an info2 file. I don't see it. I may have to turn on like system files. Maybe I don't have that on. So this representation of these files is not true for that directory structure. This is the real files. So you understand what I mean? So if I was at a DOS prompt and I searched for a file, I would not find cats.doc. It might show it to me here, but that's what I would be seeing is everything deleted from the C drive, sequential one, zip, blah, blah, blah. So I would have to know to go look at the trash can. And so this picture here is completely wrong from that standpoint, because even though they have names and the contents there, this is all processed data and it's not the real data. You can have deleted files also that aren't showing here that I can also recover, and you get a $R and a $I file, and you have to know what each one of those files are. So when you're doing a recovery, if you see $R and $I, those are previously in the trash can that are now deleted. So that's what they will be in Vista and later. XP and earlier will be the DC file names that I showed you before. In rfidi-util, you can just run it on the directory for the recycle bin and it will tell you what all the data is. It processes the $I files. They go in pairs. So when you're looking at the content, every time that you see one, there's a pair that goes together. They're like this. So every file that has a number, 18A506, there is a real file that will be 18A506. The exe file, the one with the R, is the real file. It's a real executable. If you rename that file to bob.exe, you can run that file. You can just hit enter and it would run bob.exe. The information about that file and its real name and its real directory structure is in the $I file. So everything goes in a pair. Okay? The previous way was just the info2 file, and the info2 file I broke down in hex. It's all sequential and it's all in hex, and you have to use a hex editor to do this. So basically you'll have to parse all that. It's not terribly hard to do, it just requires some practice for you to know how to convert dates and times and things like that so you know what file you're dealing with. But it will tell you what that data is, and there are tools that will parse it for you. This is another problem that's a normal problem for Windows, is if I took somebody else's Windows hard drive that had a recycle bin on it, a C drive that I recovered and I imaged, I plug it into my drive, and I see their recycle bin on that C drive. When I double click on it, Windows will automatically redirect me to my C drive's recycle bin. So I'm not actually seeing that recycle bin, I'm seeing my own recycle bin. You'll see files you recognize in that recycle bin. They aren't that guy's files. Understand? It's a redirect process, and actually one of the first tools that was written that was a mounting tool for Encase and for others was Mount Image Pro. You guys remember that? They had a real bug in it in the first round. When they released it, they didn't stop that redirection process from happening. So later on they had to change that and update the version so that it would kill the redirect. So that when you're examining somebody's drive, you didn't accidentally examine your own drive. You did examine your own drive. And you gave evidence back that was your files, not their files. It was a very easy problem to occur. Okay? Good so far. All right, so info 2, blah, 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 trash can. For those of you who don't know the folder structure, it's very similar to Mac's now. Very close, actually. Thank God we finally got there. All right, so here's a really awesome tool, a really easy way to get some data back if you have Vista and later. From Vista on, they took snapshots of the data as a backup live. Vista was actually, did it quite often. It backed up its data all the time, so it was a live backup. You know what Time Machine is, right, Tim? This was live Time Machine on your local machine. It literally made backups to your local hard drive all the time and took snapshots. You would use a tool to look at it, and you could parse out data a week ago, 2 weeks ago that the client had already deleted, that it would make snapshots. Now, in Windows 10, it's further apart. It's like once a week. Like once a week it takes a snapshot. It used to take a snapshot every day. And now it takes a snap. Then it was 3 days, and now it's a week or something like that. So every week to 3 weeks you'll get a snapshot of backup files for the last 3 weeks or so. So if a client deleted something, you could actually go and get it back. There's a tool, and it is called, it's a free tool again. You can donate to the guy for his work, but the guy, some forensics tools take this called Shadow Explorer. Shadow Copy is making a copy on Vista 7, 8, and now here's the thing, you'll hear people say, the home versions don't do it. That is a lie. The home versions do it. What they don't do is give you an interface to recover your own files. So there is no recovery. I mean, the people who need it the most, they took it away from them. They only gave it to the enterprise people. But it does work. It still makes an image all the time of all Vista 7, 8, and 10. They'll always make a snapshot of their data. This tool, Shadow Explorer, all you do is install it on a machine, and it looks like this. It's very simple. You point it at the drive. You point it at the drive. They walk you through it step by step. You point it at the drive, and this is what happens. Shadow Explorer pops up. It looks at your C drive, and it'll give you the date and time it took a snapshot. And you drop this box down, there's going to be whatever times are available on the machine. They're stored in the system volume information folder. XP and earlier only did drivers. Vista and later does all the files, including Word documents, Excel documents. I mean, the hardest one's email, but outside of that, everything else is live. It does snapshots. So these are all the things that changed, and these are the files in those directories that changed. So you just look at the machine. I mean, I call it low-hanging fruit, because in the very last scenario, if I haven't gotten the file back from someone, I just go ahead and run Shadow Explorer and see if they ever had it. I see what they did. So Shadow Explorer, you can just extract the files that you want and save them, and that's it. But every Windows machine from Vista and on makes snapshots live all the time. Mac's got nothing on them. There's not anything even close. The closest thing they have is they accidentally duplicate every file in the duplication folder. That's it. Like if you open a Word document and you edit it, it makes 2 copies of it. So things like that happen all the time, but this is really valuable from that standpoint. So it's low-hanging fruit. It's very easy. It's really just a utility. Bitlocker. So encryption does not stop me from fixing and imaging a disk. I can still image any encrypted drive unless the board is encrypted, and then I got to get an unencrypted board or something like that, which they do sell. You can buy to get past the encrypted boards themselves. Some boards are encrypted on hard drives if I'm repairing them. And so talk to the Google group when you run into one. If you can't access the board and it's locked, they'll tell you who to call. It's usually a guy in Egypt. And he fixes the boards, and he somehow unlocks all the boards, and he can sell them to you for like 80 bucks. And then you can get into your drive. Now, it's not fixing encryption, it's just getting around the firmware lock to stop you from getting into it. You still have to have all your passwords, you still have to have your keys to get into any encrypted drive. If I image an encrypted damaged drive and I get 92% of a BitLocker or a PGP drive, they will decrypt properly. 92% is the magic number. If it's less than 92% of the drive is copied, it probably will not work. It almost always has worked for me if I get 92% or more. So if I have a small handful of sectors that does not work, we do BitLocker drives all the time. But they got to give us the key. We're not decoding it. I'm fine if they don't give us the key, if they know that that's what they're doing. I have several agencies that send me BitLocker drives that are damaged. I image it. I don't ever have the key. I send back the copy that I have, and they unlock it. Sony does that. I've had a couple of like that where they're BitLockered, and they don't give us the key. They just have us repair the drive, re-image the drive, and send back what we have. And then they unlock it. Everybody good with that? I can image all of them. There's very few that I cannot image. Okay? If you have an encryption chip on your board, then you do have to go through that process of decryption, and only one right now can be decrypted by PC3000, and that's that Western Digital with the 7 keys. It can decrypt the hard drive itself by finding the flaw, and that's it. Otherwise, you're going to have to resort to hacker tools to try to get around all of your other processes to try to get past them. All right, so we've talked about pretty much all of this. Let's talk about Windows now for a minute. Macs now for a minute. So Macs and HFS. So here's the primary story. HFS. So what page is this? Anybody? 105. So Steve Jobs works at Apple. He creates a whole nother department that creates a fiasco inside of Apple because at the Apple II was doing really well, and he wanted to make a Mac because he went to Xerox PARCs and he saw the Xerox PARCs graphical machine that they had. They had 3 primary things that he saw that he said were amazing, that were earth-shattering, that he wanted to build. Object-oriented operating system. That was the number 1. Number 2 was networking, and number 3 was the graphical operating system with a mouse. Those were his 3 primary things that he saw, because you had communication, you had the graphical interface with the mouse, and you had operating system that's object-oriented, means that you don't have a lot of crap on it. It literally reuses modules from itself in the process. And so his goal coming back to Apple was to, or at that time, walking back to Apple, was to create a Macintosh, which the first one was Elisa, named after his daughter, which he said wasn't named after his daughter, but then later he admitted it's named after his daughter. Anyway, there's a whole story there, because he was a terrible person. Steve Jobs might have been a great and terrific salesperson, and pretty good from a standpoint of at least knowing what the future was going to do, but he was a terrible person and a terrible father. But that aside, so he comes back to and creates this Macintosh, and it's going to be released in 1984. The very first ad was the Super Bowl ad. If anybody remembers the Super Bowl ad, they got Ridley Scott, who did Aliens, to come and record. It only aired once, ever. It's an amazing ad from that standpoint, but it was basically 1984, George Orwell's 1984, and utopian society that was basically falling apart. So his idea was, I'm going to have a graphical operating system, nothing else existed like it that was commercially available, and the Mac could talk. So he gives a demo. They sell apparently millions of these right away, and it had a unfinished file system. The file system was literally crap. It was a terrible file system, and it was called MFS, the Macintosh File System. So they already knew that they were going to have to replace this before the Mac would live on. So they had another team working on a new file system to replace the Macintosh file system right after it was released. I don't know how they were going to get all the disks to them because we had no internet. We had nothing. You have to go to the store and get it or something. So the Macintosh file system only lived for 9 months. It was only on the machine until the middle of 1985 when it was replaced with HFS. And that is when Steve Jobs left. Steve Jobs had hired the guy from Pepsi, John Scully, and basically John Scully ousted him because he was creating havoc inside the company, and maybe rightly so. At this point, who knows? Steve Jobs probably did really well because he got kicked out. So the Macintosh file system lives on without him. He leaves, and they make no progress for 12 years. Literally, Macintosh sat on their ass, made some add-ons to their graphics, and that's it. By the time that they were done in 1997, they had done 8 versions or 7 versions of the Macintosh file system, only adding graphical stuff back onto the back end. Apple was spending money trying to make a new operating system because the old operating system now, from the 80s to the 90s, is dying. They cannot keep it alive. And it's being outperformed by everything that Windows is doing by that time, because Windows is now graphical, OS2 is graphical, everybody else is graphical, and so they have no solution. So Steve Jobs comes, so during that time period that he's gone, he makes the Next. So the Next is a computer based on BSD. He said, I'm not rebuilding this, I have very little money, I don't have a whole big team, so I'm going to make a new machine. He had no file system for the machine. So he went and used BSD and regenerated BSD as the core in Darwin, and then from there on added on the front end of a graphical GUI based on Solaris. It was based on the Solaris, except he wanted to add objects. He did not have objects in Macintosh file systems in the beginning. He only had that in the Next, and he made like rip array modules and things that installed together. DLL hell did not exist on a Macintosh like it did on PCs. So his entire point of making the file system was, when you install a utility, everything that goes with that utility is packaged together. It's not a zip. It's not a zip. It's not compressed. It's not anything except a logical unit, kind of the way the MFT is. It's a logical unit that just exists together by the operating system binding those things as one item. So when you see, even today, so a Mac today is Next. It still has pieces of code running in the machine that are the Next pieces of code. So when you see something like this, this is one of the things that he did. So he created it so that when you do an install application, there's really not an install. All it does is take a package of data, bind it together, and drop it into the application folder. So every one of these items that's in here is not really an app or an executable the way that you're used to seeing an executable on a Windows machine. If you right-click on it, there's an item called Show Package Contents. When you look at it, you'll see it is a folder that the operating system just treats as a single item. And that single item has all the things that you would have had in we didn't have a registry back then, there's no registry on a Mac. A Mac doesn't have a separate database running like that all the time. Its only database is HFS. So HFS as a catalog is running and keeping track of all the resources that this device is using. So the package contents all go together. And so this is what he was doing as a object-oriented item, is that you can treat this whole thing as an object and reuse the objects, rather than doing what DLLs do, where you have to keep following them around. So every single item has something in here, and so your real executable actually could be a script, a file, it could be anything. It can execute, and it's all controlled by how this package is set up and what its resources are, and the info plist is the equivalent, this is the easiest way to say it, to an entry in the registry in a Windows system. They're basically the same premise, and they can be compiled and stored in binary so that they don't grow and they're not too long. Most serial numbers for most applications on a Mac are in the info plist. They're in a plist file. They're not stored in almost any other format, so it's easy to copy for a Mac it and all of its serial numbers and keep your software running. If you use a Windows system to copy a Mac, you get this structure. It does not know how to package the data together, so you see an individual structure of all of these items together. Now, that is only really a problem, kinda, for applications. But where you'll see that again is this. So, what the Mac likes to do, and what they did with iPhoto and all their stuff after 2006 as they continued to go forward, making new packages, is they decided to wrap up stuff. So when you look at Aperture, used to be a program for editing graphics and doing things. Nobody pretty much has that anymore. The big one is the photo library. So the photo library is where every photo is stored. When you use the little photo button and everything's inside the machine is stored there, and it looks like one single file. Again, it is not a single file, which thank God it is not, because that would be a nightmare if you're doing JPEG recovery. Because JPEG recovery could be just embedded inside of a database and compressed, and things would happen. You really can't compress a JPEG, so all that would be happening is you're adding more content to your database than you need. So they did a package. And it didn't used to be a package. It used to actually just be left alone as a single solitary item until 09, I think, 09. And then so the iPhoto library, when you show the package contents, this is the structure of their database. So the content here, your real files still exist. You still have your original masters. They're all stored internally inside the file system by their date and time. So you still have your actual file stored there. So you'll still have all your JPEGs as separate items, which is why you can carve them so easy. There's a second reason you can carve them so easy. 3 minutes after a Macintosh is booted, any file 20 megs or less is automatically defragged. So it automatically always goes after the files and defrags them and keeps them contiguous on a constant basis, never stopping. Part of this is because the HFS file system would fall apart if it had to jump around all over the place. It's very important for its algorithm to stay intact and go like an org chart does all the way down through the tree. That's how come it stays fast. And so it is overburdened at this point because HFS is also 30 years old. The addition of the items that they added to HFS are all the BSD functions, so all the things that you can see that are date and time and structure that have to do with attributes of BSD, the things that are these, all of these structures, all of this stuff down here, all of this is the stuff that has been added. So these are your permissions, read, write, group. So all of this will look familiar to Linux and Unix people because these are all the same settings that Unix uses for its permissions for files and access. And so all of this detail it was added to HFS Plus. So HFS was 12 years old, and then they added HFS Plus to include all the attributes. And then in 2002, because the Macintosh laptops were having problems when they were out in the field, they added journaling. So there is now journaling function, and it works almost identical to the way the Windows journaling function works, where a transaction dies and it just deletes the file. So Macs are looking for that to rebuild themselves, and they have a tool to do that. But if it gets stuck on a binary tree, it eats itself. It can't fix itself. So it's a terrible way to repair something. It's a way better thing to go and image the drive and then try to repair something so you have a backup copy, because when that tree gets corrupt, it does not know how to repair it, so it just cuts off the branch. It just kills the branch, thinking, oh, dead is better than my system's not running. So whenever you see that happen, it's a good thing just to stop. So all of these attributes and all of these things are the things that were added in 1997 until 2002. There was a big problem with processors. Intel had basically taken over at that point. And Motorola and the PowerPC could not keep up with the production of processors, especially portable processors. So from 2002 to 2005, Motorola never came out with a new laptop processor. So Apple was really pissed off, and that's why they switched over to Intel. So they had already been in the design works to switch all of the laptops to an Intel processor so they could keep going forward with new stuff. And in 2006, switched over all of their code to Intel, and 64-bit processing is now 100% done. Like the newest version cuts out all previous 32-bit code and is 100% 64-bit. And so if you have 32-bit code, you either had to migrate or do it, use it going forward, or you lost it. You couldn't use it anymore. So they've spent 6 years trying to get everybody off of 32-bit code. And that's why in their app stores, they just, and same thing happens on the iPhone. If somebody doesn't stay up to date on their new app, they just cut it out, and then you can never download it again. So it's just gone. Like anything that was from the last version, if they haven't updated to the newest version, eventually the store just kicks them out altogether, and you never see the app again. So out with the old, in with the new. Now, one of the reasons I'm bringing up this package thing and how this works with applications is it should be obvious why it looks like this, because this is the way an iPhone works. All of this stuff, when they installed the app, it was genius from that standpoint. They don't have to go into the operating system and lay anything out. They don't have to do like Windows systems do and install stuff all over the whole hard drive. They literally have every single thing they need in a single package. There is nothing that the rest of the system needs from a standpoint of DLLs or anything like that from any place else. They're included in the package that comes with it. So that way the versions always stay with it until it's updated for that package. And so everything's just treated inside of a Mac as something you can drag and drop and move around. But when you process it and you do a recovery, because I don't do recoveries from a Mac for a Mac. I do my Mac recoveries on a PC because the software is so much better. The only thing I have to pay attention to is I will break these packages. So these packages will start to literally come apart, and unless you keep everything intact when you plug it back into the Mac, it will not. The applications won't come back. But I also find that almost no user cares about the applications. They can just re-download that application in a heartbeat and instantaneously be back up and running, unless it's Office or Adobe. Those two are the only two that key to the system and have like an active service that goes and hunts down an active license. Everything else, the serial numbers and everything will work. The downside is for if you're on Adobe or Lightroom or any of the ones that have to do with graphical apps, you know how you can buy filters for cameras and software, and so you can then process like Lightroom and stuff on your own? Well, on a PC, those will go into the program file directory or your application data directory, and so those will be part of your user or part of the actual folder structure of the program files, which you can access without having to have a password. On Mac, they actually install inside the app. So inside the app's location, so if I find Aperture as an example, if I have filters, Aperture inside, if I bought filters, they will be in the plugin directory. So any filters or anything I added on is here. So this is the custom stuff that the person wants. So if you want, you have to track down any of those programs. So you have to ask them, well, what graphical apps do you use? Anything that might have plugins. It's going to be all in the plugins directory. Same thing for Adobe. So Lightroom, I don't know if I have it on here. I think I do though, right? Maybe not. Any of those that are graphical applications like that, they'll all have their filters inside of the actual content. Let's see where else I've got something. Like a lot of these others will never install anything else inside their own tool, so it's not a big problem. But any of those that are graphical apps, they'll all have those as a plugin from that standpoint. So I don't see anything. So I only use this for training, teaching, or testing. So I don't do any other stuff. AutoCAD is one that usually does it. So there'll be a plugins folder. Not this one. And then the plugin folders will be all the filters. So those will be the things you have to recover. The rest of the stuff no one cares about. So I don't usually use the Finder. I don't like the Finder, kind of like what happens over on a PC. So I use this tool. I don't know if anybody's ever seen this before. This is called Pathfinder. And Pathfinder, again, split screen. I have a lot of options. I can look at stuff. I can redesign my layout. It's not as full-featured as Directory Opus. It doesn't have all of the features that you would want, but it does have a tool set in it that you can use. And it does have like sliding windows and things that you can do. Multiple tabs. You can open up a tab across the top and have another folder structure, so you can switch back and forth. So if you're trying to find something that's close, that's the closest thing that you'll have to use. And it does help me at least navigate the file system from getting things done. Now the other thing is, if you're coming from a Windows world and you don't know commands, there's a lot of commands. If you plug in a hard drive into a Mac and you try to recover from it, if there's any problem with the drive, there's something called disk arbitration. And disk arbitration locks the drive's use. You can't control it, you can't stop it, you can't do something with it. It auto mounts and tries to automatically look at all of its files. If you're going to use the Mac as a data recovery machine, you need to turn off disk arbitration. And there are some people who have made some tools that you can just click a button and it runs the script automatically and does disk arbitration. But the problem that you'll have as being a Mac user or a Mac owner in any way and trying to do some technical stuff is the new commands every time a new operating system and anything comes out. So there is a company called RixStep, and RixStep.com. And RixStep has been around for a really long time. And so RixStep makes their own file system. So they have a new file system. I don't know what that is about. Maybe the guy who made it died. I don't know. Cool. All right. Anyway, so we'll get into that. RixStep makes a bunch of tools, and so they make individual things to try to help you with the file system, to manipulate the file system. And so they have their own, basically a Finder. So they have their own version of a Finder so that you can control things inside the file system. So they make a ton of tools that you can use. They are not free. They sell like a bundle and a license and the whole thing. Some of the tools are free. And there is one that's called Clicks. Clicks, right here. So Clicks is pretty awesome. Clicks itself is kind of like a list of database files. So Clicks has all of these items in it where you can mount and you can execute code. And it's basically, you know, like you would see like those Linux user guides that you would buy or a small Mac OS user guide. Here's what Clicks does. Clicks is basically a blank slate, like starts out like this. When you download it with all the little databases that go with it. So it has a database, and you can't see it from that side. But I'm going to open up the database for disks. So there is a disk command set. And so these are all the commands that you would use for disks. So here's all the items that you would be looking for. I don't know how clear that is. But so the very first thing is they try to show you what you can do, what you're looking for, how to turn something on and off, what your command is, and then you can actually execute it from in here. So there is a double-click execute. You can change it, make notes, add your own scripting process in it, and it becomes like a command line utility driver / book because they'll tell you what it does in the process. So when you're looking, you know, how to show fixed disks, these are all your commands. So they'll tell you all the stuff that you need to do to control or not use something. Now, when a new version of an OS comes out, like we just got Catalina, what are the different? Now I didn't download the new guide for Catalina. Here's Lion. So Lion, all the commands that changed for Lion when it came out, this is it. So every time that they come out, they'll add, every time they come out with a new one, they tell you the changes. So these are the things that changed in Lion and all the commands. And every once in a while they make some major command changes, and you're used to using an old command and now the new command doesn't work. So you have to go find the new command. So all of these items are the things that will help you do that. So you can, for each version, and this is all free, so this is one of the things that I use. So just keep in mind when you're dealing with Macs, if you are going to do a recovery from a Mac, there's only like 3 pieces of software that you can use on a Mac for recovery that even matter. Not the Mac itself, because the Mac itself can't really repair itself. There's Disk Wizard, which I'm not a big fan of, because Disk Wizard or whatever runs through the drive, and Disk Warrior, I'm sorry. Disk Warrior runs through the drive and tries to basically do a repair on the drive while the drive is live. So I'm not a big fan of that. But there is another tool called, and the reason I'm bringing this up is because the headers from every operating system are slightly different. So even though RStudios has a list of headers for Macintoshes to carve, it's not always right. The headers that are in a Mac, some of them are different, and for some reason RStudio, even though they make a Mac version, has not updated the headers. And I know this from experience because QuickBooks is one of the ones that's different, and they don't have the correct QuickBooks one in there all the time. So, so the next tool is called Data Rescue Plus. Data Rescue Plus, I think, is version 4.5.5. This one's actually pretty thorough. It's one of the few that is thorough, and so this will actually cut through a Mac and recover files that, oh, Jesus. And so this one will actually do a pretty good carve process. So if I have a Mac that I haven't been able to recover in some other way, this is what I will do, is I will carve with this tool or recover with this tool in the hopes that I can get a little bit better than I would have under any other condition. And then the other thing is RStudio has a Mac version. So you can use RStudio to do some things, but keep in mind, again, and it does have an editor, which is good. So you still have that, but Data Rescue Plus 5 is the one. I'm using 4 still, but this is one of the better tools that you can use to do some recovery that I've tried and true, like it actually works. Now, besides that, let's talk about what happens to migrate. So I take a hard drive out of a Mac, I clone it and image it on a DeepSpar. I've got a good copy. I've got a pretty good copy. I don't want to just reinsert that copy back into the Mac if I can avoid it, because still same thing. If you've got any bad sectors, any files that don't work. So here's what you do. You can go into target mode on a Mac, and you can image out whatever you want if it's an internal drive. Anybody use target mode before? So basically you hold down T when you boot, and it acts like a external hard drive. And then you can plug that into a Windows machine and make an image. So if I have an error, I'm not going to take it apart in order to get to the files, unless it's damaged, then it's not going to make much difference anyway. So if I take out a hard drive and I want to put it back into a Mac, what I really do is I make an image of the drive, I install a new OS on Mac OS, and then there is a migration wizard, migration assistant. So you know Windows has a migration assistant too, right? It doesn't work. Windows does not work correctly. The Mac one does. So when you do this migration assistant, it will read from your hard drive. It will read all the data in its original structures. It will recreate your user, recreate your background, recreate every icon on the desktop exactly the way it was, and copy all of the user's folders back into those directories and recover your entire system for you. So I do not try to take an image of a Mac and put it back in a Mac. I take the image of a Mac, I reinstall the operating system, I hit the migration assistant, plug in the drive, select all the stuff, and walk away. And tomorrow, on a brand new drive, brand new setup with a new OS, I will have migrated all of my users' data, because it does it without it being with the operating system. So it'll migrate the whole thing. So it'll only take me about 45 minutes to install a new operating system and then plug in the Mac's drive and suck it all back in. Everybody understand what I'm doing so far? So this migration assistant will do that for you off of a data recovery that you've done, and it will put every icon back. It'll install everything except the operating system's drivers. So printers, network filters, tools that are network filters, because sometimes some people have those things. Things like that will not work on the drive again. Okay? Outside of that, most of the RAID arrays that I've run into that have anything to do with Macs are software RAID arrays. And the software RAID arrays can all be processed inside of our studios. It's nothing different about a software RAID array, except for whatever choice that they made for 0, 1, or 5. So those are your 3 choices for how you do your software RAID arrays. Most people are just using a stripe set or a mirror set. That's all they're using. So I don't normally have to deal with RAID arrays on a Mac. It's super rare. I haven't had to since the Xserve, since the server that used to exist. Okay? All right, so back to here. That's kind of my spiel on a Mac from a standpoint of recovery. HFS HFS Plus is a wrapper around HFS. So they actually literally took an old HFS, created a file that says where are my files, so that if you plug it into an old system, it'll actually tell you you've got to upgrade. And so there actually was one, and they actually did do this in the process. Now, HFS Plus is a B tree, and because it's a B tree, what it does is it automatically rebuilds the entire tree every time it's 2/3 full. Now, Apple is a little bit like Microsoft in the fact they don't tell you everything you need to know. I wish they did and they documented it well, but they did not. And so here's what I can guess. Anybody know what page we're on? Okay. So the spiel is like this. So every time that the branches are 2/3 full, then they will automatically start to split to the next node. There will always be the same number of nodes. So it looks like this. They basically look like an org chart. And so every time that as your header starts to fill up and you start getting, now the maximum that I can tell fits in a node structure is 10,000. So I think there's 10,000 items in every node. And when it gets to around 6,000 items, so that it doesn't fill up the entire node, because it can't reach, if it reaches 10,000 it dies, like 9,999 it dies. So at 6,000 they automatically branch it into another branch. So it's constantly rebuilding its branch. There will always be the same number. There won't be any stragglers. It's not like one branch will be longer than the other branch. All the nodes will always be wear leveled, and you'll always have the same number of nodes. So as you have 10,000 unique items that are created in the file structure, it will make a new branch and wear level them across all of them. So it is constantly rebuilding the catalog structure for HFS, which is why it's a real problem, because as we got more and more files, HFS started to kind of crap out on itself. It would fall apart. So I'll show you, so on the computer in front of you, there is a piece of code that I have. I'm going to close all these windows. So if you're closed and there's nothing there, there is a piece of code that I have called HFS Explorer. So if you look on the right hand side, up from the bottom, there'll be an item right here called HFS Explorer. This is kind of hard stuff to get to. Even in case and stuff, they filter out a lot of the data and make it look like Windows data. It's very difficult to really look at it as actual raw HFS content. So this is one of the few tools that will kind of give you a good layout of HFS. So if you open HFS Explorer, now this piece of code is actually Java. It only works on Sun Java. So if you want to install this on a machine, you've got to install Sun Java. Now, there is a file near the file we were just working on, the NTFS file. There is an HFS file. So I want you to go to File and say Open File System from File is what it's called. Open File System from File. Because we're not looking at a hard drive, we're going to look at an image file. And when you do that, I would like for you to go to C:\Data Recovery Images. And then in there, there's one called Mac OS X. And when you go into there, there's one called Mac OS X Boot. And then there's a DD image. And that's the one I want you to open. Everybody good? Tim, you all right? All right, so that's where we're at. I'm going to open this DD image. And now you'll see it'll ask you about the partitions. Now Apple makes a patch partition. So Apple actually, when they update, they load everything to a patch partition, then they reboot, then they apply all the patches, then they reboot and activate the original partition back again. So they have a process that they do this patching. Now we're going to be looking at the one called HFS Untitled 2 Apple HFS. So I think it's the one that it selects by default. So click that and say OK. Now Apple's file system is basically a Unix file system, so they look the same as what we've seen for everything else that has existed since 1997 at least. Before that, that is not how it looked at all. So from here on, all of these items, now we'll have characters that we cannot support in Windows. So there are items I can actually extract data. Like I could right click and I can extract the data and spit it out. But when I run across a character that is not supported in a Windows system, it just crashes. Like it just stops doing it. It just says goodbye. We don't support a tilde or whatever, and just stops doing it. Some data recovery software does that. RStudios has a replacement character. So you can say any character that's not supported, replace it with another character. So RStudios has a box for that in a Mac or Linux or whatever, and you replace it. If you do that, then linked files don't work, which Mac users don't use very often. Windows users use them every day. They link Excel spreadsheets together and databases together all day long. Mac users don't seem to do that. They seem to be a lot simpler than that. In the process, what I wanted to show you, because this looks like every other directory structure you've ever seen. You've got your users, here's your user folder, here's your content, blah, blah, blah. Nothing special. Looks like any other file system. Go to the Tools window, the toolbox at the top. There is one called File System Info. This is one of the most valuable windows that I have ever seen from any piece of software, because Encase hides this, FTK hides this, even Xways, it just tries to make it look like a PC. Let's just fit all this stuff into a PC's structure. So there's a volume signature for this drive. It's H+. If I searched the hard drive for H+, I'll find that sector where it exists, and that will be the beginning of the partition. I happen to know it's at 409.640. That's where it exists. So 409.642 will be where the character is. The partition's 2 sectors in front of the partition structure. So if I search for it, I'll find an H+. So all drives that have HFS Plus on it will have that signature. It'll be H+. And so you can see all the stuff and all the attributes. So there's a lot of content that's in here that you can then track that I cannot see in any other forensics tool. I don't know why they're not publishing it. I don't know of any that give me the link, the issue, when, and all the journal mounting stuff or anything like that. But even that's not the most important part. Under the catalog content, you can now see the entire tree structure. So in this catalog content, these are the branches that it starts to make for nodes. And those are the items that are in there. So number 1 makes sense. It should be Mac OS X. It is the format and the installation. So it is the first entry. And then from there, you'll start seeing the branches, and it'll start breaking that content out. Every little tiny thing that touches this drive, every text file, every resource file, every plist file, every graphic, everything makes an entry. And so that's where all this content sits. So you'll start seeing them in their inode tables. So an inode is the equivalent basically to what we point to in clusters. So it's basically the same premise. So basically this is the information that you're looking at. Now when you pick an item and you look at it, I don't care which item you look at, the whole point is that this is where you'll be able to parse the data. Certain items have different types of data. So the catalog changes how much data it stores depending on the item. So if I go look at a file, here's what I see that's unique to me. So I'm just clicking on a file. So you can pick any file that you want and you'll see this change. What I'm looking for is, this was the one thing that makes HFS so old that it really needed to go, that we really needed a replacement for it. It's because the content that it's tracking inside of the file record is non-critical information included with critical information. So the reason that we have a registry in Windows is because the file system is critical. If you want to keep your system running, you want to keep all your files alive. Inside of Windows, they did not want to shove a serial number for a file or the window sizes for the files into the entry for the file system. So we have a registry that does that. Does that make sense to everybody? Now, it is much later. You're talking about almost 20 years later they created that. But if you look down the list here, you're going to see that inside some of these boxes there is an item. It might not be in the one I got here, Finder Info. There are some of these that will have a Finder box for, say, Adobe or something like that, that tracks the Windows location and the scroll bar's location. So you know how the Mac comes back up and all your stuff goes back where it was, and then even your scroll bar and how far you were down in a Word document all be in the same place? That's what it's doing. It's tracking all that stuff, and those pieces are tracked inside of HFS. So let me see if I can find one that shows, maybe a plist will tell me. No. I probably need to find an actual document or something. And then you'll actually see the content that's non-critical with critical data. And so that's a real problem. I have a photo of what some of that looks like. So you can see in HFS, if you ever need data, I'm still going to this tool and looking at things that if I'm doubting what's going on inside of Encase, I tend to go to other products and go look at something else. Or if I'm in X-Ways and I want to see it in a raw format, I try to go someplace else. Also, that RICSTEP tool also has an HFS discovery tool, so you can kind of look through the file system differently than what all the other tools are doing. So B-tree is basically hashing in this entire process and rebuilding that entire tree structure. So that's the closest I can get you to the structure without spending a pile of money to get you wherever you can see it. And so the catalog, again, is the replacement for the MFT for us in a Mac. And that does have all the same entries, basically, that we have inside of a Windows. We have a parent ID, size, content, root directory, where it all is. So there is all the same processes. And again, I've already described some of this, like the file record size, the metadata, all the things that go with it. Here's the biggest thing. Like inside of here, certain files, like here's an RTF. So this RTF actually has not only that content, but you'll actually see the scroll bar's location. Like it'll actually show up in here that there's actually the scroll bar's location in a Finder. So there are pieces of non-critical information that are in there, and if you are doing something, it can cause corruption, and then HFS cannot survive through the process. So again, of the tools that you can use, it's going to be kind of the same stuff that we've already been talking about, all the software I pointed out earlier, but that's how you'll get around most of these things. This is the list I already told you. If it's less than 20 megs and it's been booted for 3 minutes, it automatically defrags. This is obsolete at the moment. Surprisingly, what happened is Macs over time have become more Windows-like. Seems strange to say that. I don't mean to abuse you in the process. But Macs used to do what was probably correct, which is if I took a folder and I copied it to another folder, then it would ask you, oh, well, these two folders have the same name. Are you sure you want to do this? You say yes. What it did was destroy the old folder and then replace it with the new folder. Well, that's not what Windows does. Windows merges the two folders. So if you have files that are the same name inside the folder, then it'll either overwrite or ask you if you want to overwrite those files, but the ones that aren't the same name, it adds them to it. So you end up with a conglomeration of the two together. But in a Unix platform, it would say you can't have two of the same thing, so let's delete this one and replace it with this one, because a folder is also a file. So you used to lose them all. Now they add them together. They do exactly the same thing that Windows does. So if you drag it over, it'll now see the folders are the same, and then the same names for same files will either overwrite or ask you, and then the rest of them will be merged into the same directory. They also changed how you look at disks. We, in the Windows system, are counting size by 1024. They are counting size based on meg. So if you say, I have 1 gig, then it's 1,000. So the size of files inside of a Mac since Snow Leopard, which has been 2011 or whatever, the size of the file in the Mac is counted as a 1,000 instead of a 1024. So the two sizes will not match. When you compare them, you have to copy it off, and then it'll take up a different amount of space than you expected on FAT or whatever else, and copy it over to a Windows system. Does this make sense to everybody? So your file system is counting in a different denomination from that standpoint, instead of doing it under its normal conditions. And then target mode. So target mode allows you to hold down the T as you're booting a Mac. It exists on almost all Macs. Not all of them can do exactly the same process, because some of them didn't have Firewire and some of them didn't have Thunderbolt. So a few of them would not work. And so once you could do this, you can actually then access the drive or use it for storage. Now on newer Macs, after you got past,
The T2 chip.
well, even before the T2 chip came out, you could not access one Mac without a new Mac that was the same rev or number since, it hasn't been that long. It's only been like 2 years. So in the last 2 years, so if you need a Mac to access another Mac, you have to make sure you're on the same version or later. You can't access with a pre-OS. So, all right. So I'm using Mac Drive as one of my options to read a drive. Now, if you, on these machines running in front of you, they do have Mac Drive on them. If we mounted a Mac's file system in any fashion, you'll see that the Mac disk will show up here. And I'll show you how we can do that. So on the machine in front of you, surprisingly, this used to be a really incredibly difficult thing to do because you had to spend some money or try to find a tool that would do it. Now I'm done kind of with this tool. I'm closing it. FTK Imager 3, one of the reasons that it's on the computer is it has the ability to mount a disk as a virtual disk and plug it in. So it pretends I'm a disk and plug it in. You have some tools that cannot access the binary file and that you will have to mount that image. Okay? So if you open FTK3 and open the same file that we just opened, the Mac boot. So hit plus, go to the image file, and go get the Mac OSX boot DD. And say finish. You got it, Tim? Say finish, and then you'll now see it inside of FTK where you could extract the data. You could go see the data, extract the data, do whatever. We are going to mount this. So if you right click at the top, you go to the top of the tree where it says OSX boot, right click and say mount image. Or image mounting, sorry. Image mounting. Say that, and it will now put that name there, and it'll give it a drive letter. So you can say the next available drive letter. You can also try to decide read only or not, but read only is what it should be. Everybody good here? When you say mount, you'll see it do it below. You'll see, oh, I've mounted an image on your drive. Now, if you are on a Windows system and you do not have a tool like Mac Drive loaded, you do not have an HFS driver. So it would not mount the drive in a way you could see it. You would mount it, but it would be raw. It wouldn't know what you had. You'd just have a drive mounted. Does that make sense? Everybody happy with that concept? So in this case now, you'll actually see if we open my computer. So on the bottom there's a computer, or if you open my computer from there and you open, again, directory Opus or anything, you will now see that HFS did mount. I have a driver, and it processed it, and now I can treat a Mac as if I would any Windows disk. Does this make sense? So in this tool, you'll also see there's a little tiny Apple symbol there next to the hard drive. So it's trying to indicate to you that that is an Apple hard drive. So there will be a little Apple symbol there. But now I can copy and paste and do whatever I wanted to with files between the Mac. Now I've got it set as read-only because I'm trying to recover from it.